So your first step really is just to factor the denominator, whether it's just taking out a common factor, whether it is factors of the last term that add up to the middle, whatever it is to do that factoring, you're going to factor the denominator. So here my denominator factors, I can just take out an x, and I have x plus 3. So those are my factors. And so then I'm going to break this down with those as my denominators. So I'm going to say, well, that means that this original problem here should equal some number over x plus some number over x plus 3. Right? And when it's just set up like this, you just have to do that cross multiplication thing, where you multiply each piece like that. All right. And so that means that 6x plus 15 could equal a times x plus 3, and then plus b times x. And so then you're going to distribute this guy, ax plus 3a plus bx. I have a feeling these are going to be easy ones here, this particular one. That means my coefficient in front of my x is going to be the coefficients of my x over here. They were very nice. And my number is going to be my number. They won't always work out that beautifully where you can just solve. Now, if you can't just solve, you have to solve by some method, meaning you solve by Kramer's rule, which is really what we've been doing this chapter. In this case, you can just divide by 3, right? And you know that a is going to be equal to 5. Plug it back in, so b is equal to 1. And my final answer is 5 over x plus 1 over x plus 3. What can happen is you can have repeated factors. So when I factor this, I get x minus 4, which is just x minus 4 squared as my factors. And so when I do that, I'm going to set it up with my a over x minus 4 to the first, and then b over x minus 4 to the second power. And you could keep going to the third power. However many times it repeats, you have to build up to that.
Only if they're both x minus 4.
If it's repeated factors is the key here. That this same exact factor twice. All right? And so for this, my common denominator is actually just x minus 4 squared. So this doesn't need anything added to it. This is just going to be x minus 4. So this guy is going to be pretty straightforward as well. ax minus 4a plus b. So negative 5 is going to equal a, and 24 is going to equal negative 4 plus b, negative 4a plus b. So then b is going to equal 4 when you solve that. Plug a in. And once again, you just go back up here and plug them in. A is negative 5. B is 4. And you are done.
Why is it just B?
And for this one, you're going to factor factors of 8 that add up to 6. That's 4 and 2. So my factors here are x minus 4, x minus 2. So I'm going to set this up. A over x minus 4 plus b over x minus 2. So I'm going to multiply this by the x minus 2 and this one by the x minus 4. So 7x. So 7x minus 20 equals, distribute here, ax minus 2a plus distribute here, bx minus 4b. And here you're going to set up two things. The coefficients, that's my 7, is going to equal my coefficients here. And my number is going to equal the numbers here, negative 2a minus 4b. This is where you're going to use your matrix to solve, Kramer's rule. So I'm going to say my determinant, that's going to be 1, 1, negative 2, negative 4. So that's negative 4 minus a negative 2 my x determinant. I'm going to replace my x with the 7 and the negative 20. And that's going to be negative 28 minus a negative 20, so that's negative 8. So negative 8 over negative 2 is going to give me my x, which is 4, or my a rather. So then now that I know that a is 4, I can just plug it in right here, and I know that b is 3. So if a equals 4, plug it in, b is going to equal 3. So then my final answer here is going to be a over x minus 4 equals b, not equals, plus b over x minus 2.